Okay, so where we left off, we had looked at this income offer curve. What I want to do now is to look at another related idea. It's called a price offer curve. So this is just another way that we can graphically show the relationship between what a person will buy and in this case the price, right? So in the IOC, we hold the price as constant and allow M to vary. What we do now in the price offer curve is instead hold the price of bananas constant, hold M also constant, and now change the price of apples. So, the sort of intuition behind this idea is just to say, well, how would your optimal bundle change if we change the price of apples, right? So that's what we're going to see here with the price offer curve. Okay, so let's look at sort of similar examples of what we saw before. So we'll look at this perfect complement utility function. So the utility of A, B is the minimum of A and B. And so here we have to set a particular value for M, right? Rather than letting M sort of range all over the place, what we do instead is to say, okay, let's say M is 6. Let's set PB is equal to 1. And now PA is going to go all over the map, right? So PA will go from a very small number like 0 up to some gigantic number. And so that's what we're going to see in this example. Okay, so I think you have enough information now that you can take your best shot at writing down what J's price offer curve looks like. And I'm going to suggest that you do the exact same strategy that we've seen before, right? So if your first step is drawing a curve, I would say that is extremely bold and extremely confident. I mean, if you are feeling quite confident, then go for it. But the sort of more standard approach is, okay, well, what's J's price offer curve? Well, look, we have to basically do something for lots of different values of PA, the price of apples. So let's just try some simple stuff, right? Let's see what happens for some various different values of the price of apples. And maybe that will give us some more clear ideas about this person's buying behavior before we actually go to draw the price offer curve. Okay, so this is just repeating the problem. So let's suppose that the price of apples is 1. Okay, well, we know that we want an equal number of apples and bananas, right? There's no sense in having 10 apples and 2 bananas. That would be a waste of money. And so this person can afford 3 completed pairs. And so I just show the calculation that I did here. So, the calculation that I did here is, well, a pair costs $2, right? Because apples and bananas each cost $1. And so you can buy 3 pairs, and that would equal your $6. So if PA is 1, then you can get these 3 completed pairs. And so your optimal bundle is 3, 3. Okay, so let's just do the same thing. So let's say, hey, what happens instead if your price of apples is 2? Well, if your price of apples is 2, well, you want an equal number of apples and bananas. And so you can afford 2 completed pairs now. Because a completed pair, well, it requires $2 for the apple, $1 for the banana, and so that's $3. So you can think of a pair costing $3. And so you can buy 2 pairs. And so that means that you just have an optimal bundle of 2, 2. Okay, so what does that mean? So I would say an extremely reasonable guess here would be, okay, I guess the price offer curve is the entire line where apples equals bananas. Like that entire line that has a slope of 1 that runs through 0, 0, 1, 1, and just goes on forever, right? So I would say yeah, super reasonable guess. It turns out that's not quite right. There's one more wrinkle that we need to think about that never really came up in our income offer curve. And so the idea is you can't get like a huge number of apples and bananas because M and PB are fixed at 6 and 1, right? So even if the price of apples is like super, super small, like it's a penny, well, you still can't get a bundle like 100 because you can't afford 100 bananas, right? So that's the sort of new wrinkle for this problem. It's just we have to figure out where this curve ends, right? The other curves never ended because as you got more and more money, you could buy more and more stuff. But here, even if that price of apples gets incredibly low, well, there's still, you just can't buy too many bananas. Okay, so even if you go all the way down to the very bottom where the price of apples is 0, well, then you can get 6, 6, right? So that's the highest that you can get to if you want to have an equal number of apples and bananas. So I would say a 99.999% correct answer would be drawing a line from 0, 0 to 6, 6 and saying that's the price offer curve. So the sort of like weird extra wrinkle. And I do want to be clear, this is a minor point, right? So if you are confused by this last bullet point, don't sweat it. It is definitely not the main focus of this question. But here's the idea. If you have the price of apples is literally 0, then 6, 6 is optimal. Right? You spend all your money, you maximize your utility. 6, 6 is optimal, but 7, 6 is also optimal, right? You know, apples are free. It's not that 7th apple doesn't give you any utility, but it's not costing you any money. And so it's like, sure. So you want 6, 6, you want 7, 6, you want 8, 6. All of those are optimal. So technically you have this sort of funny like vertical tail attached onto your diagonal line. Let's take a look at what that looks like. And so here you go from 0, 0 up to 6, 6. And then you just go straight vertically forever, right? Because you could have like, you know, 1,000,000 apples and 6 bananas. So that's how you know that this curve actually does sort of go up forever. Okay, so that is that example. So I think we're ready for a new example here. So our new example is just that J has the utility function of u of AB is equal to A plus B. And we're going to set M as 10 and the price of bananas is 1. Okay, so what does this mean? Let's just sort of reflect on this for a second before we dive in. So utility of A and B is equal to A plus B. That means A gives 1 utility, B gives 1 utility. Oh, right, we've seen this. This is what we call perfect substitutes. What that means is this person is always totally indifferent between 1 apple or 1 banana. And they're just equally good to this person. You know, sometimes in my head, I like to think about Coke and Pepsi for this example. You know, if you just don't care about the difference, right? If you feel like Coke and Pepsi are always equally good, then that's then this utility function could describe your feelings about Coke and Pepsi. And so this person, for them, an apple is always exactly as good as a banana. And then we're going to fix the price of bananas at 1. Okay, so we'll do the same thing. So, you know, in our quote unquote small groups, we'll really do, you know, the sort of individual work here. And we'll take a look at J's price offer curve. And as I've said, you know, a million times today, I think the best way to do it is just pick some values for PA. Figure it out for a handful of values, and then hopefully you'll see that pattern and you'll understand what's going on for every value of PA. Okay, so let's do this. So let's take a minute right now, work on that, and then we'll come back. Okay, so I'm going to assume now that you have taken that minute and sort of struggled trying to figure out what Jay's price offer curve would be. And so let me present my solution now. Okay, so I guess before actually diving into my answer, I do want to just sort of mention something. So notice that apples and bananas are always equally good. And so something that's really useful for our answer is that that means that Jay will always just spend all of her money on whichever good is cheaper. Right? Imagine going into a store, you would think Coke and Pepsi are identically, desirable, and one of them costs 5 cents less. Like, great, just give me all of the one that costs 5 cents less. Like, I'm not going to buy like a mix. There's no point in buying a mix. I just always want the one that's cheaper, and I'll spend all my money on the one that's cheaper. There is this sort of edge case where what happens if they have the same price? Well, if apples and bananas have the same price, then Jay can just buy any combination. As long as she spends all of her money, it's going to be fine, right? She's going to get that maximum utility because these two, well, each one gives the same utility. And so that means that as long as she spends all of her money, then it doesn't really matter what she buys. Okay, so let's just do the same thing. Try some different values of PA. So let's suppose we try PA is equal to 5. Okay, if PA is equal to 5, then apples cost more than bananas. So she just buys all bananas, right? And so she can buy 10 bananas. So that's 0, 10. Okay, so 0, 10, that's what she would get if we had PA is equal to 5. PA is equal to 3. Wait, this is the exact same story. Right? Apples cost more, so she buys all bananas, so she buys 0, 10. So this is really helpful, right? It means that anytime apples are more expensive than bananas, well, we can just kind of stop working right there, right? We know that as soon as apples cost more than bananas, she's going to buy all bananas, so she's going to buy the bundle 0, 10. Okay, what about when the price of apples is 1? So when it's exactly the same as bananas? Well, in that case, we know that apples and bananas cost the same. And so 0, 10, that maximizes her utility. 10, 0, that maximizes her utility. So does 9, 1 or 4, 6 or anything at all maximizes utility as long as she spends all of her money. And so that's all that she has to do in order to get the maximum amount of utility. Okay, and then the sort of last chunk of the values for the prices of apples is just anything between, anything where the apples cost less. So for example, if apples cost 50 cents, well, apples cost less than bananas now. And so she buys all apples. And so if she buys all apples, she can buy like 20, 0. Right? She's not limited to just 10 items. If apples are cheap, then she can buy a lot. And in fact, if apples are really cheap, like if apples cost a penny, then she'll buy all apples, and she can get 100 apples and 0 bananas. And so, of course, what I'm doing here with these very small prices, just trying to figure out like kind of the extreme cases in the price offer curve. Right? Like, should we be thinking about a curve that goes for a little while and then stops, or should we be thinking about a curve that goes like forever? And so here we see, you can get a gigantic number of apples just by making the price of apples super, super small.